quick video overview that is looking at the ecological niches of common Vermont trees. Now, in terms of your work, you are going to be using models that have been developed by the United States Forest Service through the United States Department of Agriculture to consider different ways in which trees in Vermont may or may not be leaving or entering or changing their distribution and density. Now, within the different species you can explore, I have given you what I think are the most common species that we would have seen out in our forests: the American beech, the balsam fir, the eastern hemlock, sugar maples, eastern white pines, and the spruce. You certainly can go to this website and find other trees on the list if you need to, but I think these would be the most important. Now, your job is to take a look at a variety of different maps and models that are discussed within each of these trees' atlases to consider the questions that we see in bold. I am going to go through each of the figures right now for the American beech. That way you feel a little bit more comfortable with what each map is showing, and that should help you with work later on. So I'm going to first go to the American beech. And the model is sort of broken down into two aspects. We have the current distribution of the American beech and the modeled future habitat of the American beech, as well as the life history. So let's take a look at our first map that we're going to be looking at, which is going to be of the Abundance Little Ranges map. So to do that, we are going to go to Abundance. I'm going to click on it. Let's hope it clicks. This website was designed a while ago. And then we're going to go to the second tab, which is the IV with range of the United States and Canada. So this is showing me the current extent of the American beech based on what's known as the FIA importance value. The FIA importance value is a calculated value of density and biomass and importance of that tree species within the broader forest ecosystem. A score of 0 means that that tree is not present, and a score of 51 to 100 means that that tree is very important and very dense within that forest. We can see within Vermont that we tend to have a north-south density distribution with a little bit of some differences within the Champlain Valley and a little bit over by St. Johnsbury, but generally we go from an FIA value of about 11 to 20 to about a score of 1 to 3/4 to 6 as we move north and south. Let's go take a look at some other things. The next is going to be the hotspot map. And the hotspot map is going to be defined as where the FIA score is in the top 10% of importance values for different forests. So if I look at the hotspot of Vermont, our hotspot is actually not, or the beech tree does not have hotspots within Vermont, but rather within the Adirondacks. And that's an interesting thing to consider, given that they're roughly at the same latitude. They're both coastal but inland biomes with mountains. Something must be going on there. And that would be discussing the hotspot map. The third map that we can go to is the niche map. And the niche map is going to sort of show us a variety of different distributions. Now, to use the niche map, you are going to be using the color-coded keys for the eastern climate, elevation, and soil graphs. This is going to show us the eastern U.S. climate, and it's going to show us that roughly we tend to see beech trees scattered within biomes that have roughly this range in precipitation and this temperature. We can look at elevation, and it looks to me as if the FIA score is roughly around 40 to 45 in terms of latitude, with an elevation somewhere between 2 to 600. That's where we tend to see most of the reds, which have the highest scores. And then we can look at soil, pH, and permeability. This seems to be a very specific type of soil, meaning that it's a lot less spread out. It looks like the red dots are more acidic and tend to have lower permeability. Permeability being how fast water moves throughout it. So again, we're going to be looking at temperature and precipitation, latitude and elevation, and soil pH and permeability. This is basically telling us about photosynthesis, temperature, and also nutrient availability. The fourth thing that we can go to is the geographic predictor map, and this one is a little bit confusing. The directions are here, but I'm going to walk you through it. This is going to be showing us a hierarchy of variable factors that really are important in terms of the most to the least important factors that determine why a birch tree may or may not be. Whenever you see these arrows, if that factor is greater than that, you will move to the right, and if it's less than that, you would move to the left. Alternatively, this would be saying if forest is greater than 52.5, you would move here. If it's less than 52.5, you move here. You have different predictor acronyms. Predictor acronyms are described here. So for example, my first acronym is agricult. So I'm going to go down to land use, and it's going to say the percent of land that's cropland. If the percent of cropland is greater than 50% in your state, you would move to the right, and if it's less than that, you would move to the left. Assuming that Vermont has more than 50% of the cropland, you may research that, or you might just imply it. The next most important factor for why a birch tree might be there is the temperature in July. If the temperature in July is above 19.5, you are going to move this way. And if it's below 19.5, you're going to move this way. So what does that mean? In a state with 50% of its land as agriculture, the second most important factor as to explaining why a birch tree might live in the state is its average temperature in July. If it's above 19.5, we're going to move to the right, which means the minimum elevation is going to be the most important factor afterwards. If the temperature is less than 19.5, or greater than 19.5, then we're going to be moving over to the average temperature. Again, when you see these two arrows, if the arrow is pointing to the right and it's greater than, that means the July temperature is greater than 19.5, we go over here. If we look at this equation and 19.5 is bigger than the average temperature July, we then move over to the right. This is going to show you a hierarchy of less and more important factors. Agriculture greater than 50% to the left, agriculture less than 50% to the right. I'm sorry that I got those two arrows mixed up. Agriculture greater than 50% to the left, agriculture less than 50% move to the right. The last thing that you're going to be looking at on the left side is the summary, or you're going to look at the current statistics and table page for this, which is right here. And this is going to show you the importance score for each of the different variables in terms of their importance from greatest to least. And this will be a way for you to double check your work. It looks like the mean elevation is the greatest and overall importance factor for explaining why a birch tree may or may not be living in a climate, followed by agriculture, followed by forest, followed by temperature in July. We then can look at the summary change map, and the summary change map is going to be over here. And I believe we're going to be looking at the differences between the FIA current to the Hadley high and Hadley low. So this is the FIA current that's showing the current distribution of birch trees throughout the state. The colors are a little bit different. And we're going to then look at the importance values for the Hadley high and Hadley low in terms of how these colors and these distributions change. What's interesting to note is that the birch trees do not really change their geographic span. They do become more common in the Hadley high versus the Hadley low in the southern hemisphere. But when it comes to Vermont, we still see birch trees in both states, or both models. However, the change in importance value becomes very noticeable in the Hadley high model as opposed to the Hadley low. We can then go to look at the potential changes in mean center of distribution, which is going to be right here. And this is going to show us how the middle location of a beech tree's density is going to change in different models. And when we're looking at this, it's a little hard to see. You're going to have different colored circles and different borders showing that current distribution. So the green dot currently is the specific MC, and then we can look at the different values that are occurring with the low and high models. I believe the red dot is the Hadley high model, and that is showing a very large shift southwest as a result of it. And the overall importance of it is also going to be shifting to the south, which is interesting. Many trees that we are going to be looking at are actually doing the opposite. We can look lastly at the life history and disturbance response. And with this, we can look at lots of different things that beech trees generally need. So we can talk about, for example, the type of things that they need within their niche. They need well-drained, coarse-textured soils. They flower in the late spring, which is important for the reproduction. They need cold stratification, which means they need cold nights and warm days during the spring for their seeds to germinate. They prefer this type of substrate, light, moisture, and temperature, and they respond to disturbances based on fire, weather, and exotic or invasive species as a result. These different things might give you some more information as to why these trees might be changing their distribution or density within the state. In terms of your responses, I'm not looking for long paragraphs. I am looking for you to write specific observations using data that you can find within each of the figures that I just went through. I hope this is helpful. If you have more questions, feel free to see me in class, before school, or during flex, but also work in groups based on the need that arises, not doing the same trees in the same work, but supporting each other with the figures. I hope this helps. Have a great rest of your day.